thing that we're going to practice, we're going to do one slide, we're going to go fast, is greatest common factor. The other term you're going to hear me say it all the time is GCF. You're going to hear me constantly say GCF, you have to take out a GCF, you're supposed to do a GCF. Because that's the first step to every factoring problem. It's also the easiest step to every factoring problem, and it's always the most forgotten step of every factoring problem. So people just seem to whiz by the greatest common factor and don't even do it because they learn these harder techniques and then they try to do those first. Greatest common factor has to be the first thing you try every time you factor. Greatest common factor is when you have something like this question, so it's a binomial, you're going to look at all of the coefficients. The coefficients are the numbers in front. So 9 and 15. And you're going to ask yourself, what's the biggest number that can divide into 9 and divide into 15? The answer is 3. Then you're going to look at the letters. And you're going to check every term, and you're going to say, what's the biggest number of x's that can go into x squared and x? And it's just x. It's always going to be your lowest exponent. And if I tried to take an x squared out of both of these, there wouldn't be enough x to divide out of the second. If I just took one x out of both of those, that would work. This thing right here, that's your greatest common factor. What you do is you divide all of the terms by that greatest common factor. And that's going to leave you with something in a set of brackets. So your greatest common factor always comes out in front of a set of brackets. If you take that 3x, you divide both terms by it. I'm going to go 9 divided by 3 is 3. X squared divided by x is x. So the first term divides to just become 3x. The second term is going to become negative 15 divided by 3 would be negative 5. X divided by x, they cancel each other out, right? They would just be 1. We don't need to write like 1. This would be my factored equation. I took out a GCF, it left me with 3x minus 5. Yeah.
Do we have to deal with like the x equals 3x plus 5 or whatever that is? Or the, I can't remember what it's called, where you, so it would be positive 5 divided by 3.
Yeah, we're going to have to do a little bit. Not a lot, but a little bit. Alright, try it again. So we look at that one, we have negative 4xy squared, negative 18x squared y squared. The biggest number that can divide into both of those would be negative 2. Because they're both negatives, I'm going to take a negative out. If only one of them was negative, I'd probably leave it in. But because they both have a negative, I take a negative out of those. I have x squared, and I have an x, so that means I can let me know 1x. And I have a y squared and a y squared, so I can take out a y squared. So that thing right there, that's my GCF. To figure out what's left over, you divide each one of your terms by the GCF. So when you divide this one by negative 2xy squared, you would be left with positive 2. And that's it. And negative 4 divided by negative 2 is positive 2. And then the x's cancel and the y's cancel. The second thing, divide that by negative 2xy squared. Then you're going to be left with plus 9x. Again, all you're doing is you're pairing things up. Numbers divided with numbers, and the letters divided with the letters. So 18 divided by 2 is 9. X squared divided by x, you subtract the exponents to just give you 1x. Y squared divided by y squared, completely cancel it out. Alright, we have 3 questions right here. Try all 3 on your own. You're just making a greatest common factor. So as you do those, you should have run into a couple of problems. So the first one was pretty much straight up. A 5 could go into both numbers, and an x could go into both letters. So a 5x came out, left you 3x minus 7y. There was nothing tricky about that. The next one, though, has something a little bit tricky to it, and it's the fact that you can't take out any letters. Okay, so you can take a 6 out of all three of those numbers, 12, 18, and 6. However, you can't take an x out because you can't take an x out of all the terms. This is a trinomial. You need to be able to take an x out of all three terms to make that thing work. You can't, so you can't take out the x. What you're left with is not 2x squared minus 3x. You're left with 2x squared minus 3x plus 1. So don't forget that 6 divided by 6 doesn't just cancel out. It leaves you with plus 1.
Could you die? No.
You could, yeah. We will. Alright, number 5. The same problem happened in the fact that we took out an entire thing. So you can take out a 2, an x squared, and a z to the power 4. That's the entire first term. So again, you don't just get rid of that first term, it becomes the 1. This guy has to be there still. So make sure that if you have something completely factor out, it doesn't just disappear. If you GCF a trinomial, you should be left with a trinomial. If you GCF a binomial, you should be left with a binomial. Alright, the next type of factoring we're going to remind ourselves how to do is trinomial method, where we use the diamond method. So when we want to factor a trinomial, the first step is still going to be to do a GCF. So you're always going to check and be like, hey, can I take a GCF out of this? The question is I can't, or the answer is I can't. That's when you then move on to your next step. And your next step is to figure out how many terms you have. If you have 3 terms, that means you have a trinomial. That means you use the diamond method. Okay? To factor a trinomial, you always do diamond method. It's the most popular type of factoring we're going to do this year. Okay, so it's probably the most important. To do the diamond method, you draw a diamond. So I draw it for you. On the top of the diamond is something called your A times your C. When you have a trinomial like this, we call it in general form. So it has to look something like this for you to be able to use the diamond method. You have to have an x squared term, an x term, and then a constant term, something with no x. This is called general form. The top of your diamond is A times C. So in our case, it would be 1 times negative 8, because that's what A and C are. So the top of my diamond is negative 8. The bottom of your diamond is whatever your B value is, which would be plus 7. The sides of your diamond. The sides of your diamond you have to create yourself. You need to find 2 numbers that multiply to be the top and add to be the bottom. Yep. Oh, so negative 1, positive 8 would add to be 7 and multiply to be negative 8. So that's exactly what we want. Negative 1, positive 8. Now the diamond method isn't factoring. The diamond method is organizing your factoring. The factoring now comes in to the fact that we know when we factor a trinomial, we're always left with 2 sets of brackets. We also know that the very first term in a trinomial comes from the very first terms in my 2 binomials. So the 2 things that would multiply to the x squared would be x, and it's almost always going to work out that way. Yeah, it'll always be something squared, or else it wouldn't be general form. Yeah. So I know I'm always going to have an x, and an x is my first term in each. The second term in my brackets comes from the diamond. Negative 1 and positive 8. Order does not matter. So you had x plus 8 and x minus 1. That's the same as x minus 1 times x plus 8. That thing is fully factorial. If you're ever unsure about yourself and you want to figure out, hey, did I do that right? You could multiply these two things back together and they should equal whatever you started with.
And it doesn't matter what order you write this in.
Any order, yeah. Okay, we're going to do one more together and leave two for you to do. So I have a trinomial. It's in the upper form, which is ax squared plus bx plus c. Where a is equal to 1, b is equal to 7, c is equal to 12. The top of the diamond is a times c. Bottom of the diamond is b. Next color looks a little messy. The sides of the diamond are two numbers that multiply to be the top, add to be the bottom, 4 and 3. If you're ever unsure of what multiplies to be 12 and adds to be 7, focus on just the multiplication. Because there's a limited number of things that multiply to be 12. 12 and 1, 6 and 2, 4 and 3. Only things that multiply to be 12. So one of those combinations has to add to 7. If it didn't add to 7, you would say it's unfactorable. Okay, the next part is I know when I factor a trinomial, I'm left with two binomials. So I just like to draw my brackets up first. The very first term of my quadratic, or my trinomial, has to come from the two first terms multiplied together. So my x squared has to be x times x. The sides of my diamonds now become the second parts of my binomial. X plus 4, x plus 6.
So if it was a negative, you put the negative in the brackets too? If it was like...
Negative x squared or something like that?
Yeah.
Well,
like
if there was a number there, yeah, we're gonna have, like if the sides of the diamond were negative? Yeah, then it would be negative 4.
Okay.
Okay, I want you to try the next trinomials, factor them. Remember, the first thing you check for is a greatest common factor. You also have to have a positive a value to factor. So that fourth one, you need to be very careful with. But give it a shot.
Would you factor in negative 3?
That's exactly what you got. Factor in negative 3 rather than a positive. Okay. Hopefully, you factor both those beautifully. The trick with number 4 is you have to take out a 3, and you have to take out a negative 3. So when you do diamond method, your a value has to be positive. If it's a negative number, you can't do it. Okay, so just a note to yourself, a value has to be a positive value. So when I took out my negative 3, I was left with this new quadratic. From that is when I now did my diamond method on just this portion. And the 3 still stays out front. It doesn't go anywhere. So a GCF that comes out at the start of the question should still be at the front of the question. It should be the same. Okay, those factoring problems, or diamond method problems, would be considered easy diamond method problems. The reason why they're easy diamond method problems is the a value is equal to 1. And there's also no other letters. There was just x's. These problems would be considered more challenging problems. Okay? One of them is not factorable at all. So we're going to work through the first two, and then you're going to work through the next two on your own. So, the question is, the first step is to always try to take out a GCF. Always try that. In this question, you cannot take out a GCF. No number goes into 2, 19, and 9. And no letters in all 3. But you do notice something unique about this trinomial, and it's the fact that it's not just m squared, there's also an n squared. And it's on your last term. So for now, we're going to ignore that, and we're going to talk about how we can create that later on. But we're going to pretend we're factoring it just like it's in general form. So the very first letter is my a, because it's m squared, that's my b, that's my c. Create my diamond. I have 18 on the top, negative 19 on the bottom. I want to figure out the numbers that had to be the top, right? Had to be the bottom, multiplied to be the top. I'm going to focus on the multiplying part. Things that multiply to be 18 are
Negative 1 and negative 18.
negative 1 and negative 18. So negative 1, negative 18. And here's where we're going to have a little bit of discrepancy. If you had me teach you Math 10C, I teach how to factor things one way. If you had somebody else from Math 10C, they might have taught you a different way to factor. Some of you, I don't think I've ever taught math. So that could be a little bit of a difference. How many people had Miss Tuck teach them Math 10 or Math 20? Okay? And how many people had Miss Shaw do 10 and 20? Okay. And a few of you had me, right? So the way that I factor this, and I'll show both ways. Neither way is wrong or neither way is right. They both get the same answer. It's just two different methods. Okay. I much prefer mine. That's why I teach it my way. But they much prefer theirs. That's why they teach it their way. So feel free to pick whichever one you are comfortable with. The way I do it is I know when I factor a trinomial, I always end up with two binomials. Always. So I'm going to draw my two binomials. I also know that when I create a trinomial from two binomials, my first term always creates my first term of my trinomial. So I need two things here that would multiply to be 2m squared. So I need m and m, obviously, but I also need one of these to be a 2. And I don't know which one is going to be a 2. I have no way of telling. So I make both of them a 2. And I know that's wrong. Like, I know I can't have two 2's, because when I multiply together, that would create 4. So I'm knowingly making a mistake, and I'm going to fix it in a minute. But I knew I had to somehow get a 2 here, so I went 2 and 2 like that. Then the reason I like my method is the sides of the diamonds, they still just come in naturally. So minus 1, minus 8. I'm not done. When a equaled 1, that's when I would stop. When a doesn't equal 1, I do diamond method, and then I divide. So I do diamond and divide is what I call when a doesn't equal 1. The reason I have to divide is I purposely made a mistake. I have too many 2's. So I need to divide one of those binomials by 2. Which one can divide by 2? The one on the right. And I'm not doing a greatest common factor, so don't make that mistake. I'm dividing out my mistake, my intentional error. I'm fixing my error. So my final answer would be 2m minus 1, and then m minus 9. If you had somebody else teach you how to factor, what they would do is they would go to create their diamond, which they did, and they would say, I know I have an a value of 2, I need to divide one of these sides of the diamond by 2. And they would say, divide the 18 by 2. And then when they created their brackets, they wouldn't do negative 18, they would do negative 9. And whichever one you divided by is also the one the first value doesn't get the number. I much prefer mine. I don't care which one you use. I just care if you're getting them right. Oh, thank you. I almost forgot about that. And this question has a second little part to it. And the second part is these n's. So we have n and n squared. Something else I know about trinomials is my last term is always created by the two last terms in my binomials. So if I ever want to create n squared, instead of putting minus 1, I'm going to put minus 1 n. And instead of minus 9, I'm going to put minus 9 n. And what that's going to do is it's going to create my n squared, and it's going to create my my m n's. From when I do 2m times 9m, and that would fix it. So come to a specific answer.
So even if there's 3 not 3 ends in trinomial, only with 2 ends in binomial.
Yeah, because they would multiply together to become the n squared, and then when you FOIL, like if you were to multiply it together, the mn term would come from the outside to the inside. It just has to be 9n, yeah. It's just that whatever the size of the diamond were that came in, it's just an n. That's all it changes. I'm glad you remembered that. Okay, number 6. So we're going to do this one together. The first step to every factoring problem is GCF it. This one can be GCF. You take out a 4, you end up with 3m squared minus 4m minus 1. And if you then saw you had a trinomial and you tried to factor that thing, you'd be looking at things that multiply to be negative 3 and add to be negative 4. And there's no values that can do that. The only things that multiply to be 3 are 3 and 1. I'm never going to get 3 and 1 to add to be negative 4. Okay, so that's not going to work out for me. So this thing could be factored. The only factor you could take out was a GCF. It would not be diamond method factoring. I lied. We're still going to do question 3. You can do question 7. You can do question 8. First step to every factoring problem. Take out up. Okay, can't do GCF. Second thing you do is you recognize you have a trinomial. To factor a trinomial, you use your diamond method. To use your diamond method, you need to know A, B, and C. On the top of your diamond is A times C, negative 42. On the bottom of your diamond is 11. The two sides of the diamond, things that add to be 11 and multiply to be negative 42. You got it?
Negative 3, 14.
Negative 3, positive 14. Would multiply to be 42, negative 42, and add to be 11. If you were stuck on that one, which I don't blame you if you're stuck on that, what I do is I create something called a multiplication chart. And I focus on the things that multiply to be 42. In this case, it's negative. And I write out a list, all the things, and I start with 1 every time. So I go 42 divided by 1 is 42. And I go 42 divided by 2 is 21. And I go 42 divided by 3 is 40. I go 42 divided by 4 doesn't work. 42 divided by 5 doesn't work. 42 divided by 6 is 7. 42 divided by 7, I've already used the number 7 in my chart, so that's my entire chart. That's when I know I'm done. When I've used the number already that I'm testing, I'm done. One of those pairs has to work every time, or else it's not factored. Alright, now that I've done my diamond, I create my sets of brackets. Because every time I factor a trinomial, I get 2 binomials. The first term always comes from the first term of your binomial. 6x squared. I know I need x and x, and I know one of them has to be a 6, but I don't know which one. So I make both of them 6. And I know that's wrong. I know that they can't both be 6. I know that doesn't make sense. But I'm purposely putting 6 and 6 with the knowledge that I'll fix it later. The sides of the diamonds now come in. So it's 6x minus 3, 6x plus 14. Alright, I screwed up, right? I put 6 and 6. And I know I need to fix that screw up. And I fix it by dividing one of them by 6. Unfortunately, neither of those divide by 6. So I can't fix my mistake by dividing by 6. How can I fix my mistake? Divide by 2 numbers that multiply to be 6. That's perfect, and I heard a couple of you guys saying. So instead of dividing by 6, I'm going to check to see if I can divide by 2 and divide by 3 on another one. And that would be like dividing by 6. I've just broken it up into 2 separate pieces. This first one divides by 3. This second one divides by 2. So your answer would be 2x minus 1 is 3x plus. So I know I had too many 6's, so I divided out a 6, but I had to break that 6 into 2 parts that multiplied these 6. Alright, question 8. The one I'll let you try on your own. So it is hard. It's probably going to need a chart. Remember, there's also a y squared there. Alright. We did that question. The diamond sucks because it's big numbers. So things that multiply to be negative 96 and add to be negative 29 are 32. Maybe negative 32, positive 32. I then create my brackets, and I purposely put an 8 in front of both binomials. I also put a y at the end of both binomials because I had to create this y squared somehow. That y squared is the last term. It comes from my last terms in my binomials. I then had to divide one of them by 8. The first one divides by 8 beautifully, and that gives my final answer of x minus 4y, and then 8x plus 2y. Okay, that's diamond method, hard level and an easy level. If you remember back to grade 10 and even grade 11, we also learned something called the grouping method. So the grouping method was with 4-term polynomials. I don't think you're ever going to see that happen. So all you need to focus on is diamond method for trinomials and something called difference of squares when you have a binomial. So a binomial, to be able to be factored other than a GCF, has to be a difference of squares. Difference of squares means exactly how it would translate if you were to think about each thing individually. Difference means subtract. So you need a subtraction of, when it says squares, that means perfect square numbers. So when it says squares, it means perfect squares. If you don't have that, if you don't have a subtraction, and you don't have perfect squares, you can't do difference of squares. So the very first question we look at, it's a binomial. So I can't do diamond method. So I check to see if I can do difference of squares. Difference of squares means you have to have a subtraction sign. I do, right there. The other thing it means is that you have to be able to square root everything you've got. I can square root x squared. That is a perfect square. And I can square root 16. That is a perfect square. This is a difference of squares. I just tested that. I just proved it. So the way the difference of squares works, if you're just going to square root everything, and when you square root everything, it's going to leave you with x minus 4. Square root of x squared is x. Square root of 16 is 4. Now, that doesn't make sense. You can't just square root things and all of a sudden have something new. We're factoring. Whenever we factor something, we've been ending up with 2 binomials. So that means there's got to be a second binomial here. That second binomial is a plus 4 instead of a minus 4. So it's the exact same thing, opposite symbol. So the square root is the exact same. X squared is x, 16 is 4. And now instead of a minus sign, it's a plus sign. That's the only difference. That thing is fine. It's called difference of squares. I want you to try the second one on your own. So give it a shot. I'll talk through it while you try it on your own. First step is I had to make sure I had a difference of squares. I do. It's a subtraction, and I can square root everything that's present. That means I do my difference of squares, which means square root and square root. That leaves me with y minus 7. But when I factor, I know I always get two binomials, not just one.
So I also have an x plus, and it's a 1.
That's difference of squares. All right, number 3. It's a binomial. So the first thing I want to do is difference of squares. I go to do difference of squares, and I can't do difference of squares. I can't square root the number 2, and I can't square root number 18. This is not a difference of squares. And what did I forget to do here? I forgot to do it. So remember, the first step to every factoring problem is greatest common factor. Every time, you've got to look for it. Trust me, that's an easy one. People look at it, they instantly think binomial difference of squares. It's that GCF at 2, right? And then you would have t squared minus 9. And if you look inside your brackets, that thing is now a difference of squares. So you took your GCF out, and it left you with a difference of squares. So I can square root both those things. The 2 is still going to be out front, and then whatever the square roots are, so t minus 3, and then t plus 3. That is going to be your factored binomial. All right, 4, 5, and 6 are up to you. I'll write the answer on the board. I want you to try them all on your own and check your answer. Number 4. That one's a little different than anything we've seen because there's a number in front of the first thing. However, it's a perfect square number. The number 4 can be squared there. So this is a difference of squares right off the bat. You can square root both things. Square root of 4 is 2. Square root of p squared is 2. Minus square root of 25 is 5. So my first set of brackets is 2p minus 5. Second set of brackets is just 2p plus 5. Number 5 does not look anything close to a difference of squares at first. But I took out a greatest common factor, a 3 came out, and a w came out, and lo and behold, I was left with a difference of squares inside the brackets. I can square root 4, can square root x squared, can square w squared. The GCF that I took out is still in front for my final answer. Number 6 is not correct. So, notice I have a beautiful box around the other two, not the blue one, because that is not the correct final answer. What I did was I did a difference of squares. When it's square root x to the power of 4, you do get x squared. So that part is right. When I square root 16, I do get 4. So x squared minus 4, x squared plus 4. That's perfect. Why is this thing not right? It's not the lowest I can go. Meaning, I have another difference of squares in my answers. So this thing could be factored again. Much like when I do a GCF, I factor it again. I've done a difference of squares, and I was left with a difference of squares. So I can factor it again. This thing, you can square root both of them. And that'll be x minus 2x plus 2. Why don't I factor the second one? Because it's a plus sign. It's not a difference of squares, that's an addition of squares. And you can't factor an addition of squares. So that thing stays the exact same. So those 3 terms all together would be your factor. Alright. I considered with this unit not doing review with factoring because we're going to factor a lot during this unit, and I figured we could just review as we go. Then I thought to myself, the first step to every question in about 2 days is going to be to factor. So if you can't factor, you can't do this unit. So was like, it's probably important that we just take the time, review all of our factoring, give you some time to practice it before we start getting into the crazy stuff. So your practice booklet has a whole bunch of factoring. You should try to get as much of it done as you can so that you're prepared for what's coming. This thing right here is a beautiful little chart that shows you how you should factor. So every time you get told to factor something, you should always start with a GCF. Then you're going to check to see the number of terms. If you have 2 terms left, you're going to do differences squared. If you have 3 terms left, you're going to check the A value on your 3 terms. If your A value is equal to 1, you just do a basic diamond. If your A value is not 1, then you're going to diamond it and then divide out your mistake. Factoring is crucial to this unit. Can't do it without it. If you took Math 20-1 with me, this unit is very similar to the Math 20-1 unit, rational expressions and equations. Very similar. So if you've taken -1, you've already previewed some of it. If you took -2, I think you got a piece of it. But not quite as much. Factoring, super important.